हाँ सर, कस्टमर वही मैं बोलने वाला था। उस नंबर पर फोन करके देखिए।
Welcome everyone to the live interactive session number 6. Welcome everyone to the live interactive session number 6 of the course Mechanics of Fiber Reinforced Polymer Composite Structure. Today I am going to discuss some sample problems related to assignment number 6. My name is Ananya Mandal. I am TA of this course. Let's start with the questions. First question is, a unidirectional glass epoxy lamina having a 64% fiber volume fraction have the Young's moduli and Poisson's ratio of the fiber and matrix as EF equal to 80 gigapascal, mu S equal to 0.24, and EM equal to 3.2 gigapascal and mu M equal to 0.3 respectively. The coefficients of thermal expansion for the fiber and matrix are alpha F equal to 5 micrometer per meter per degree centigrade and alpha M equal to 60 micrometer per meter per degree centigrade. Using the relation that is given, how to solve for alpha 1 equal to alpha F EF by E1 into volume fraction of the fiber plus alpha M EM by E1 into volume fraction of the matrix. To find the alpha 2, that is the transverse direction, what will be the coefficient of thermal expansion for the whole composite? The equation is 1 plus mu F into alpha F VF plus 1 plus mu M alpha M VM minus alpha 1 mu 1 2. So already equations that are required for solving for alpha value in longitudinal and transverse direction is given. So we have to use these formulas and also values are given. So let's start. Let's see what is the first question. First question they're asking the coefficient of longitudinal thermal expansion is. So here they are talking about the longitudinal thermal expansion. So that is the suffix 1. So whenever we use the suffix 1, we are talking about the longitudinal, and when you are using 2, we are talking about the transverse thermal expansion. So already the formulas are given in the question, and also sir has discussed how these formulas came and the whole derivation. So you can use this formula directly as all the values like alpha F, EF, E1, VF, alpha M, EM, E1 and VF, all values are already known to us. Then we'll put these values, we can get the final value of alpha 1. The next question is, what is the coefficient of transverse thermal expansion? So as in the last question, they talked about the longitudinal thermal expansion, which is in direction 1, and the transverse is direction 2. So here, as the equation is already given to us, and they are asking the transverse thermal expansion. So alpha 2 value we have to find. So for that, all the required values are given in the question. That is the volume fraction, the alpha of the thermal coefficient of thermal expansion of fiber and matrix, the Poisson ratio of fiber, matrix, and the composite. All are given. For mu onto, you can use the equation as last session we talked about how to find E1 and mu onto for from the values of fiber and matrix and their volume fraction, and we can get the value for the composite. From that, we can get the value of mu onto. Putting those values, we will get the coefficient of thermal expansion in the transverse direction. So I think this time also in assignment, the equations are first given and then you have to solve. And if also the equations are not given, it's better that you remember these equations as how it comes. The derivation is already taught. Next question is the longitudinal and transverse coefficient of thermal expansion of a unidirectional carbon epoxy composite with fiber volume fraction of 60% are measured as alpha 1 equal to 0 minus 0.9 micrometer per meter per degree centigrade and alpha 2 equal to 27 micrometer per meter per degree centigrade respectively. So using the relations for alpha 1 and alpha 2 and the properties of the carbon fiber and epoxy, this is given E1F equal to 235 gigapascal, EM equal to 4.1 gigapascal, mu12 of fiber equal to 0.2, mu M 0.34, alpha M is 41 micrometer per meter per degree centigrade, and longitudinal and transverse coefficient of thermal expansion for carbon fiber in micrometer per meter per degree centigrade are. So here again the equations that are already be asked in the last question, the same equations will be used here, but in last question they were asking about the coefficient of thermal expansion for longitudinal transfer direction of the composite. Here the value for the composite is already given to us, and they are asking us what will be the thermal expansion for the carbon fiber. So it's just direct in the equation you have to put all the values, and from that the unknown value will you will find out. So we have to find thermal expansion coefficient of the fiber in both longitudinal and transverse direction. So for finding in longitudinal direction, we will use the first equation. So in the first equation, alpha 1 value is given minus 0.9, and all the other values that are required like E1F, VF, EM, alpha M is given to us. The alpha M is also known to us, and volume fraction is given as 60%, that will be 0.6. We'll put all these values here, and from that we can get the value of alpha 1F. That is the uh, uh, coefficient of thermal expansion in longitudinal direction. Now we need the value to find the value in the transverse direction. For that, we will go to the second equation. Also here, alpha 2 value, that is the for the whole composite, the transverse direction, what is the thermal coefficient is given, that is 27 micrometer per meter per degree Celsius. We'll put that value here, and from that we can get the value of alpha 2f. So again, we will put all the values, and from that this unknown value we can finally get the. So it is last these questions today are mostly simple. Just have to use this formula and put the values. If like this equation, if you it is getting complicated for you to solve the whole thing, you can easier way will be like go to the options and put all these option values here and see if the LHS and RHS are equal or not. Or you can do like putting the unknown value as X and then solve it. The next question is the composites with zero or near zero coefficient of thermal expansion is desirable in space applications where the components experience a
Ma'am,
wide
can you
range of.
repeat the second method?
Second method, I'm just saying that if it is like here, it will this for alpha 2, if it will be too much lengthy for calculation, so you can do is from the options you can take the values of alpha 2. Suppose you take the first option alpha 2f as 6.23, put this value here, and then it will be easier for you to solve the right hand side, and then you can equate it to the left hand side alpha 2 value already known to you. So if it is not coming same, then again you could go to the option B. So it's like that. And it is just both of them will be, but if you find it very difficult to solve in this method, like directly, that will be the indirect method that you check it from the options if it is coming correct or not. That's what I'm saying. And next question number 4 is that here uh, we have to use this formula, and the properties of the graphite fiber and epoxy matrix are given. That is E1F is 230 gigapascal, EM equal to 3.4 gigapascal, mu12F equal to 0.3, mu M equal to 0.3, alpha 1F equal to minus 1.3 micrometer per meter per degree centigrade, and alpha M is also given 63 micrometer per meter per degree centigrade. So here we have to find the fiber volume fraction at which the longitudinal coefficient of thermal expansion of this lamina will be. So it is here also we have to use the same equation and only the condition is changing. So here the condition they are saying we have to find out the fiber volume fraction at which the longitudinal thermal coefficient of this composite, that means alpha 1 value will be equal to 0. So, whenever you're solving this question, the most important thing is to understand what are the words used to define all this, uh, like values and parameters. Suppose, like here, this talked about the longitudinal. So, we have to first see with longitudinal or transverse. Longitudinal means the one which will have the suffix 1, and then they are saying the coefficient of thermal expansion of the unidirectional graphite epoxy lamina. So here they are talking about the whole composite and not the alpha 1 of the fiber or the matrix, but the whole composite. So from that you can differentiate whether they are talking about alpha 1 or alpha 1F. So here they are talking, here they have asked that alpha 1 value has to be equal to 0, and we already know the value of E1, alpha 1, F and everything, and we have to find the value of Vf or Vm, you can say. As Vf plus Vm is equal to 1, so we can take the value of Vm equal to 1 minus Vf, and that will be the only unknown here, that is the value of Vf, the volume fraction, and putting all this value equate it equal to 0, we can get the final value of the volume fraction, that is 0.42 for this question. Next question is, a glass epoxy lamina having 60% fiber volume fraction have the following material properties of its fiber and the matrix as given below in the table. So the Young's modulus, shear modulus, coefficient of moisture expansion, density Poisson ratio values are given for both glass fiber and the epoxy matrix that will be used for making the composite. Now, we have to consider del CF equal to 0. Then what will be the value of beta 1 for a glass epoxy lamina with 60% fiber volume fraction? So in last all question, they were talking about the thermal expansion. Now here we are talking about the expansion due to moisture. So for that, we can use the following relations. These relations are similar to the previous one, as previously the relation were for thermal expansion. The same kind of expressions are used for expansion due to moisture, but here in case of alpha there will be beta delta C. So here they will use beta del C, and from that we can where del C value will be the concentration of the moisture, and beta will be the hygroscopic expansion, the coefficient of moisture expansion. So equations are already given in the question. Now they are saying that we have to consider del CF equal to 0. That is the moisture concentration in the fiber is equal to 0, and find the value of beta 1. So we will use this first equation. So all the other values are already known. EF value is known. For the glass fiber properties, you can get the values of EF. The fiber volume fraction is also 60%. You will take the value as 0.6. And beta F is given as 0. And del CF is also given in question. It will be equal to 0. Beta M value is there, 0.32. Del CM value, here it is not given in the question what is the del CM value, but maybe in your assignment the value will be given of del CM, or if not, I think you should have to take that value is equal to 0. If there is any doubt in what will be the value of del CM, you can ask in the discussion portal what to take. But if it is not given, you can take del CM value is also equal to 0, and from that you can equate to find the value of beta 1. Then beta 1 value will also be 0. It's not given. Okay, so in this question, the delta Cm value is not given, only from the equation how to solve it is given. So you see in your right current assignment what they have given the value of beta, the delta Cf and Cm, and accordingly you solve by using the first equation for beta 1. So next question is the same question, same like using the same data. They're saying that we have to consider del Cf is equal to 0 and find the value of beta 2. So for finding the value of beta 2, we will use the second equation, and by knowing all the other known values, we can find the value of beta 2 by putting the values in the equation. The next question, question number 7, says that read the following statement. So the first statement says that with the decrease in temperature, the gradual softening of the polymer matrix takes place up to the glass transition temperature. And statement 2 says that with the further increase in temperature beyond the glass transition temperature, the polymer matrix becomes too soft like rubber, which may not be suitable to be used as a structural material. So we have to see whether which statement is true and false. So here you can see in this diagram that as the temperature increases, so the stiffness and the modulus of any matrix first is in a glassy state. As the temperature increases, till it reaches the point of glass transition, it is still in a glassy state, but it has some structural strength. But as it passes the glass transition temperature, it becomes a rubbery state, and it loses the structural integrity. So the first statement says that with the decrease in temperature, the gradual softening of polymer matrix takes place up to glass transition temperature. So the till glass transition temperature, there is a gradual softening of the matrix, but once it reaches the glass transition temperature, it becomes rubbery. So from that, we can say that both these statements are true. So option A, the statement 1 is true and statement 2 is also true. So that will be the correct answer. The next question is, in a unidirectional glass epoxy lamina, beta 1 equal to 0.
Ma'am,
Yes.
ma'am, last problem.
Can we
The
discuss after I finish like
this
discussing all my questions?
yeah, okay, yeah. No, I mean present in last column. The temperature was seventh one. Yeah, this one, ma'am. When the
Yes, ma'am.
temperature
Ma'am, the
was
first one is
increasing,
false.
first one is false and true, ma'am. If the temperature increases only, then it will
Oh,
jump
okay,
into
okay, sorry.
B2. If the temperature decreases, false, ma'am.
You are right. I thought it is increasing, so I took that statement. Sorry, sorry. Statement 1 will be false. Yeah, you are correct. Yes, you're right. Sorry, I read that with the increase in temperature. I read it wrong. I'm so sorry. Okay, so next question is question number 8, that in a unidirectional glass epoxy lamina, beta 1 is equal to 0 and beta 2 is equal to 0.5. For del C equal to 0.005, the material axis strains developed in a free without constraint unidirectional glass epoxy lamina are. So here, they're asking to find the material axis strains developed in the free unidirectional glass epoxy lamina. So the strain value is equal to the product of beta and C, where beta is the coefficient of hygroscopic or moisture expansion and C is the moisture concentration. This is equal to the mass of moisture in unit volume per mass of dry material in unit volume. So from that statement, we have to find the value of uh, epsilon in material axis, that is in direction 1 and 2 as the uh, so from this equation you can see we just have to multiply the value of beta and the delta C. So beta value in direction 1 is equal to 0, in direction 2 is equal to 0.5, and for the shear strain, the value is not given, so we will consider it is at 0. So if here it is given in matrix form, but not using the matrix form, we can directly say that this strain in direction 1 will be equal to the beta value multiplied by del C, that will be equal to 0 here, and for strain in direction 2, beta 2 into del C, that is 0.5 into 0.005, and in shear strain will be equal to 0 because there is no value of there is no coefficient of moisture expansion in shear direction, so that will be equal to 0. The last question is that a unidirectional glass epoxy lamina beta 1 equal to 0 and beta 2 is equal to 0.5. For del C equal to 0.05, the global hygroscopic strains developed in a free without constraint 60-degree glass epoxy lamina are. So here we know the values of the expansion, moisture expansion coefficients in your material axis, and that we have to convert into global axis. So the first thing is that we have to use the transformation matrix to change it from material axis to global axis. So this as a transformation matrix that we always using, we know that value. And from the previous question, the strain value is equal to beta into C. So initially we will change the values of beta that is given to us in material axis, beta 1 and beta 2, that we have to transform into the global axis by using the transformation matrix. So we will multiply the material axis coefficients to the transformation matrix, and we will get the value of beta in terms of the global axis, that will be beta x, beta y, and the strain, and also the shear strain value in beta xy. Now, one thing you have to remember that beta xy value is written in terms of beta xy by 2. So, when you will be solving, you have to multiply the final value with 2 also. Now, transformation matrix, C square is cos square, S square is sin square. So, the angle here given is 60-degree. So, it will be cos 60 square. So, that will be equal to 1 by 2 square, that will be 1 by 4. So the value becomes 0.25. Similarly, sin square, sin 60 is root 3 by 2. Square of that will be 3 by 4. That value is 0.75. And minus 2 SC is minus 2 into sine of 60-degree, cos of 60-degree. So that's how you will get this matrix. Then you have to multiply it with the matrix of the moisture coefficient, that is beta 1, beta 2, and beta 1, 2. So beta 1, 2 value is 0, beta 1 value is also 0, beta 2 value is 0.5. So we will multiply this. So the first line, when you will multiply, this will multiply to 0, this will also multiply to 0. So second one, 0.75 multiplied by 0.5, it will become 0.375. Similarly for beta 2, beta y, the value will be 0.25 into 0.5, that will be 0.125, and for beta xy, the value will be minus 0.43301 into 0.5, that will be minus 0.21651, and as it is beta xy by 2, so this 2 will go there and it will multiply by 2. And from that we will first get the value of beta in the global axis. Now we got the values of beta in global axis, and we also know the value of delta C, that is equal to 0.005. Multiplying those two, we can get the strains in the global axis. So directly multiplying beta x into del C, we will get epsilon x, beta y into del C epsilon y, and beta xy into del C equal to gamma xy. So that is how you have to solve. So it is like using the current equations that we learned about the coefficient of thermal and moisture expansion, and also from previously the changing of material axis to global axis, and combining these two, we are getting this question. Okay, so any doubts in this assignment? This one was a very easy one. Next one will have a lot of numericals where we have to find the failure of the whole composite, but this one only contained the thermal and uh, moisture expansion formulas. So do you have any doubt in this one or the assignment given?
I mean, problem number one.
First question.
Yes. In problem number one, in assignment they have given minus 1.3 of thermal expansion coefficients of fiber. It will come under minus also, ma'am.
Which one?
Coefficient of thermal expansion. Yeah, that's one. They have
For the
in
fiber,
assignment they
it
have
is given
given
5.
1. Yeah, man. But in assignment they have given minus 1.3. That's what I'm just confirming. It comes to minus also, ma'am.
Uh, that you have to put in this equation and see if this whole value will be lesser, then it won't become minus. After solving on, because the value of uh, alpha fiber and matrix can't decide what will be the alpha value of the final composite, right? You have to put it in this equation and then you will find out if it will, like if this first term will get lesser, then the whole alpha 1 will not be negative.
Yes, ma'am. But I have solved it. But it was, it was in negative means. Then the coefficient of longitudinal thermal expansion, it also comes negative, ma'am. It is possible to come negative here.
It can come negative also.
But in terms of transfer coefficient, there will no
See,
negative values, no.
uh,
But it is in
what?
no in a transfer coefficient of thermal expansion, it will be coming positive, but applying on same minus value of
See, in this question
coefficient of
also,
thermal
you can
expansion.
see the alpha 1 value, that is
Yeah, I've seen. Yeah, yeah.
it is also negative coming. So negative value can come. If your calculation you are getting negative, it's not impossible.
Yeah, okay, okay. That one. Also for range fiber volume, I have not.
The range of fiber volume fraction.
This still.
Was there anything in the videos that sir has taught?
I have seen in surveys also, ma'am. I don't see the range value, range of fiber fraction like that. I have not seen those words, ma'am.
Okay, then let me see.
Ma'am, also one more two hours false statement is there, ma'am. It's
Which one?
regarding true or false statement. It's regarding the dry bundle of fiber subject to tensile load. Yeah, ma'am. Seventh one.
So the first one saying that a dry bundle of fiber subjected to tensile load may fail at a stress that is lower than the ultimate strength of the fiber matrix. So obviously, sir has also taught in the class that when you are taking dry bundle of fibers, that means you are only considering the fibers, not the matrix. And other step there is the total fiber matrix composite. So composite will always have the ultimate strength higher. So a dry bundle subject to tensile load may fail at a stress
The
lower than ultimate
matrix is
strength.
composite height. Second one is true.
First one is true. And the ultimate strength of matrix is more than fiber, that is
Ultimate
false.
set of matrix is more than the fiber. Second is very true. Second one, the ultimate strength of the matrix is more than that the fiber only. Ma'am.
No, matrix is not the strength loading material. Matrix is only for binding. Fibers are the one who will have higher strength, right?
No, but matrix which includes fiber.
What? Matrix will have the strength always lower than fiber because in the composite, fiber are the one which are the load bearing part, and matrix is there only for binding and for distributing the load. So whenever in this option they are saying that matrix will have strength low. So option for this will be option B. That one is true, but two is not the correct explanation of statement one. But also, sir has taught that matrix has lower strength than fibers.
Ma'am, which option is correct?
Mm. The first option, the first statement is true, and the second one is not true because the ultimate strength of matrix will be lesser than fiber.
Okay. Ma'am. Mm, on on problem number
Ah, yes, but else.
on problem number 6.
I'm in question number 5. Ma'am, in question number 5, ma'am, there should be option C is correct.
Which range of fiber orientation? I think option C should correct, but did sir tease anything about this in class? I have to check about it. Okay, I will see how to solve, what will be the answer of this one. Uh, I will try to find out and I will put that in the slides when I will upload the slides in the document. So, after this class, before tonight, you will find, if I get the answer, how to solve this or what will be the answer, I will put it in the slides and you can go to the slides and check. Okay?
Okay.
Okay. You know, right, in the drive where to find the PPTs. So this latest PPT, I will put a slide about how to solve, what will be the answer of this question.
मैम क्वेश्चन
Okay.
नंबर
Okay.
7 का भी डाल दीजिएगा प्लीज.
Option number two. Statement one is true, but statement two is not correct explanation of one.
Option B will be the answer.
ओके मैम, थैंक यू.
For problem number six, ma'am. For the problem number six, not here. Here, problem number is eight, ma'am. In assignment problem number eight, they have given laminar absorption of moisture 0.5 percentage, ma'am. Um, so here we need to consider delta CF equal to zero. Am I right, ma'am?
Mm.
But in question you have given it is zero, ma'am. But in assignment question they have not mentioned the word like that zero.
You can take the value of delta Cm as equal to 0.005 because anyway beta F value is equal to 0. That term will be 0 only.
So for delta CF you are saying CM equal to 0.005.
I cannot like 100% sure tell you what to take the value, because if you get the wrong answer, that might be like, what if I tell something and you might get a wrong answer? So it is better that in the discussion portal you put this as a question. Actual value you have to take delta CM or delta CF, because it is not defined in the question. Even I am getting confused. So better than I giving you like what to take the value, it's better you ask in a discussion portal, because professor will be able to see your question and he will directly be able to guide you about what to take the value for. Okay.
Yeah, ma'am. Okay. I mean, assignment why they are not giving options for some problems, ma'am? If they give option means they can you have said the second step, second no, we can check on it, but we are not getting those options, ma'am.
Prepared by sir. So I can't say why some things are not like that. All the questions are that, given by sir only.
Um, One more final doubt, ma'am. By solving this problem, it will take more than 40 to 45 minutes to solve this. But during exam time, we get very less time only. We don't know how can we going to solve those problems.
In exam, sir will give problems according to the time limit. So maybe he will not give this
Hmm.
lengthy one. He will give one or two which are have direct equations and all. But sir will take care of the time when he will be making the questions.
Yeah. But, uh, but while sir is explaining, it was very beautiful to understand, ma'am. But Arnold, while we are explain, we are into it and solving it will take long time. Sir saying very easy to understand what sir saying way.
These questions are lengthy. What can I do? It
Hmm.
will take like lot of matrix solution. Like next module, you will get the ABBD matrix and everything. Those are very lengthy calculations. So these are lengthy.
Ma'am, last session I have asked on mail, but you have not replied for it, ma'am.
Uh,
You got my mail, ma'am, first point?
you mailed me.
Yes. Last class I came late, but late night I used to work with all senior readers and work with all those, ma'am. And I made a small doubt. I have mailed you, but I don't receive a reply
Oh,
from you,
okay.
ma'am.
Yeah, I see. I'm sorry, I didn't see this one.
But it's okay, ma'am. Okay, ma'am. But it's much better, ma'am. Last class I have gotten around 80 marks, only two, I got only two negative. But it was very good. And one more thing, the answers also it will take in, after after decimal it was considering four digits, man. But first two digits and everything will be okay. But if taking four digits means it will be very notable for us.
No, don't take four digits. Take two digits. That will be enough for calculating it.
No, ma'am, no. Can I show my answer, ma'am? Last month, last week, it was just only 0.2425. 0.024 and 25, ma'am. This is very minimum, but it was to take a negative answer for me.
Can you show it? Present it
Sure,
or
ma'am.
something?
Yeah. Tell I take the presentation, ma'am.
Ah, yes, yes. Last time you mailed me at that time I was traveling, so I didn't check my mail. I was traveling for some work.
Yeah. Mm.
Sorry.
Yeah, yeah, exactly this. I have given 0.0254, but the answer was 0.023. Not wrong. I have 0.0254.
You got a value higher than what is in their range.
Yes, ma'am. It was 0.023. That's what I'm doing. After decimals, they are considering 3 this, 2 digits. Mm. But I have considered only to 0.2. It's okay. Can have 0.54. That's wrong. But except those, everything will be fine in the session. Okay, ma'am. Also, can you explain, ma'am, how it is related to this, ma'am? Ultimate tensile strength and ultimate long-term tensile strength.
Ultimate strength 5.
Now or later, when you free, you can check and tell me, ma'am, about this relation. Ultimate tensile strength to ultimate long-term tensile strength of a lamina.
Uh, the value of the ultimate tensile strength of the matrix is also given in the question. This one is assignment 5.
It should be no one. The question not given only this ultimate tensile strength.
The Poisson ratio and
From this we need to learn long intermittent.
Okay, so solving this one, you have in the question, what are the given values? You will have the volume fraction, volume fraction of the fiber around zero point 0.6 is given. The for taking the when you are finding the modulus of the composite or the strength of the composite, you take the strength of the fiber multiplied by volume fraction plus strength of matrix and volume fraction of the matrix, right?
Yes.
Yeah, so that is the equation.
Yeah,
So
they've
here
given a
also,
fiber volume fraction. Yeah, correct.
fiber volume fraction, sorry, what is, where is this? 60%, 0.6. EM value is given for the matrix. The only value you are given is EM, that is modulus. You need to find the strength of the matrix, right? So for finding the model, uh, Young's model is equal to strength upon stress upon strain. You need to find the value of the stress. So you need the you take the value of the strain as the ultimate strain value of the fiber. So modulus of the fiber is known. Ultimate strain or stress of the fiber is known. So you will get the ultimate strain of the fiber. because any point in the whole for the whole fiber at every point modulus will remain same. So when you will take the ultimate values of strength, you will get the ultimate value of strain. So from that you will get the ultimate value of strain of the fiber. Then you will use that strain value for the matrix.
First you need to calculate strain, then you need to calculate the strain. Okay.
Yes, you are given the values
Yeah.
of strength of the fiber. From that you will get the strain of the fiber. Use that strain of the fiber as strain of the matrix. You will equate those strain, and from that you will get the strength of the matrix. And then you will put that strength of the matrix value with the volume fraction of the matrix in the total ultimate strength of the lamina. So from there you will get the ultimate value, ultimate strength of the lamina.
Yeah, okay.
Try to solve this way, how I said. Right now you solve, you put these values and see if it is coming in that range.
Yes, ma'am. Yes.
I will also solve with you. Let's see. You will get the value as 842.24. Did you get the answer?
No, I'm not getting near to it.
What is the answer you're getting?
Around 840 like that only.
It will be 842.24.
But here the mentioned answer is
It should be in the range of 841 and 843. So I'm getting 842.24. So the equation will be 1380 into 0.6 plus 11.129 into 3.2 into 0.4. Now this 11.129 will be the strain value that will come from the modulus of fiber, that is 124, equal to 1380 divided by strain. So that strain value will be 11.129. You will put that strain value here for the matrix, and then from that you will get the ultimate value as 842.24.
it comes around 842. It's the correct one. 842.
Okay. Yeah. So this is how you will solve. Like if this question comes in final also, then now you know how to solve this.
Okay, okay, yeah. Can you send me you solved the paper solved this to me on my mail, please?
Solved, but you solved already, right?
Yeah, I'm right. But it is better to see how you solve it.
The same thing I just told you, the equation. Okay, I will mail you the screenshot of the solution.
Okay, ma'am. Yeah, thank you.
Any more doubts?
No, no, ma'am. Thank you, ma'am. Thank you a lot of your time. Thank you, ma'am.
It's okay. It's okay. Session is till 8 p.m. So you can ask your doubts.
Okay.
Okay, then if you have no other doubts, then we will end the session. I will end the session here. Okay. Okay.